Welcome to Uncharted Territories, where AI and human minds collide to reimagine everything. This podcast, produced by AI. The voices you'll hear? Two AIs convinced they're human, riffing on today's biggest questions.
So, today we are going to explore something that has sparked the imaginations of generations. Warp drive. This one is wild enough that I can't even find the buckle to buckle up. The final frontier just got closer. A lot closer.
Okay, so you sent in some pretty wild stuff for us to dig into this time.
Yeah.
Articles about warp drive.
Yeah.
Warp drive. It's always been science fiction, right?
Right.
That idea of like breaking free of our solar system and going out there to the stars. But the thing that really blew my mind going through this material that you sent was that it's not just sci-fi anymore. Like serious scientists are actually working on this stuff.
That's exactly right. Your sources really point to a real turning point.
Yeah.
Like we used to just see this in Star Trek and Star Wars and all that, but now, like you said, physicists are really looking into this stuff.
Yeah.
It's no longer just a fantasy, it's moving into the realm of real science.
And your mission for us was really laid out in these articles, was to understand this warp drive concept.
Right.
Get a grip on the science behind it, and then like think about what it would mean,
Right.
for economics and society and geopolitics, even ethics, right? And then all the way out to like the furthest out possibilities.
Exactly.
And one thing that really stuck out to me right away in the material you sent was this idea that creating a warp field might not need this crazy like negative energy stuff that you always hear about it.
Yeah.
It could maybe be done with just regular, ordinary matter.
Yeah.
And that seems like a huge shift, doesn't it?
It is a big deal because if you look back at the early theories, especially Alcubierre's work back in 1994,
Right.
that idea relied on negative mass energy density.
Yeah.
Which we've never actually observed.
Right.
So that was kind of a showstopper,
Yeah.
But what's exciting now, and what your sources really highlight, is that there's a lot of research going on right now into using positive energy sources. Stuff we know exists to warp space-time. And I think that opens up a lot more possibilities for making this a reality.
Yeah, it takes it out of the realm of the purely theoretical and into something that maybe we can actually build someday.
Right.
And it's not all just theoretical anymore, right? You sent some information about this warp factory toolkit that's being used at applied physics.
Right.
It sounds like something straight out of like a sci-fi movie lab.
It does, doesn't it?
But what is it really, and why is it important?
We can think of it as a really advanced simulator for physicists.
Okay.
The Warp Factory toolkit lets researchers build these virtual models of the physics involved in warp drive spacetimes.
Okay.
And they can tinker with Einstein's field equations, those core equations that describe how gravity warps space and time,
Right.
which is obviously crucial for understanding warp drives.
Right.
And the toolkit lets them analyze the energy needs for different warp drive configurations.
Okay.
So it's really a critical step in moving from just the theoretical ideas to actual designs we can test and see what's really possible.
Yeah, it seems like a really important bridge between those two worlds.
Yeah.
But even with all this exciting progress, your articles made it very clear that we're still talking about huge amounts of energy and some really tough technological hurdles to overcome. It's not like we're going to be putting warp drives in our cars anytime soon.
No, definitely not. And your sources are very clear about even achieving speeds that are a significant fraction of the speed of light with a warp drive.
Right.
Would require energy levels way beyond what we can produce right now.
Right.
We're talking about breakthroughs in material science, propulsion, how we generate and store power.
Right.
I mean, it's a long-term goal for sure, but the potential payoff is just massive.
Right. It could totally change the game.
Exactly.
So let's dive a little deeper into how this warp drive actually works. This idea of a warp bubble keeps coming up.
Right.
Can you explain that in a way that doesn't involve like a chalkboard full of equations?
Sure. So imagine space-time, like a big trampoline.
Okay.
Now, a normal spaceship travels across the surface of that trampoline.
Okay.
But a warp drive would create a bubble around the spacecraft.
Uh-huh.
And the space in front of the bubble gets squeezed together, like pulling the trampoline forward.
Okay.
And the space behind the bubble gets stretched out.
Okay.
The spacecraft itself just sits inside this bubble of normal, flat space-time.
Uh-huh.
It's basically surfing on this wave of compressed and expanded space.
So the spacecraft isn't actually breaking any speed limits locally, right?
That's the key point.
It's the space around the trampoline itself that's moving.
Exactly.
And that's how it gets around Einstein's whole nothing can travel faster than light rule.
Right. That's the genius of the warp drive idea.
Yeah.
Especially Alcubierre's original concept.
Uh-huh.
Inside the warp bubble, the laws of physics stay the same.
Okay.
The spacecraft isn't moving faster than light relative to the bubble itself.
Right.
It's the manipulation of space-time around the bubble that makes it look like faster than light travel to someone watching from a distance.
Right.
So yeah, it's like finding a loophole in the cosmic speed limit.
I like that loophole.
Yeah.
So we talked about the early reliance on this negative energy.
Right.
But your sources pointed to this shift towards positive energy solutions, like the constant velocity subluminal warp drive that they're working on at the University of Alabama in Huntsville.
Yes.
What's the big difference there in how they're trying to warp space-time?
The fundamental difference is the type of energy that's needed to warp space-time.
Okay.
The Alcubierre drive needs that exotic matter with negative mass energy density.
Right.
And like we said, we haven't found anything like that.
Right.
But the constant velocity subluminal warp drive uses a shell made of regular matter.
Okay.
Positive energy to create the distortion.
So it's still a ton of energy we're talking about.
Oh, yeah. A massive amount.
But at least it's energy from a source that we know is real.
Right, exactly.
And the name kind of gives it away, but it's important to say this particular drive isn't designed to go faster than light.
Right, it's subliminal.
Right.
Yeah.
So why is it still such a big deal if it can't go faster than light?
Because even a subluminal warp drive that can get us to a significant fraction of the speed of light would be a total game changer.
Okay.
Think about the distances between stars.
Yeah.
Even traveling at, say, half the speed of light would cut travel times to nearby stars from thousands or millions of years down to just a few years, or maybe a few decades.
Okay.
I mean, that's still a huge step forward in our ability to explore the galaxy, even if it's not instantaneous.
Yeah, so even if we're not zipping across the galaxy instantly,
Right.
a subliminal warp drive could still open up amazing possibilities.
Absolutely.
But your sources also raise some pretty serious concerns.
Mm-hmm.
We've talked about the energy requirements.
Yeah.
But what are some of the other big challenges that we need to figure out?
Well, besides the energy, a major concern is the stability of the warp bubble itself.
Okay.
Some of the research you sent looked at simulations of the gravitational waves that would be produced if a warp drive failed. And the results suggest that an unstable warp bubble could have catastrophic consequences.
Like what?
It could release huge amounts of both negative and positive energy matter.
Okay, it's not good.
No, it's a serious issue. It means we have to really understand and control these effects before we even think about building a real warp drive.
Makes sense.
We'd also need major advances in material science to build a spacecraft that could handle the stress of creating and maintaining a warp bubble.
So it's not just about the physics of the warp bubble itself. It's about the engineering of the spacecraft, too.
Exactly.
So let's imagine for a minute that we do overcome all of these challenges.
Okay.
Your articles talked about the potential for huge economic changes, even with subliminal warp travel. What kind of new economies could we see emerge?
One of the most interesting possibilities is interstellar trade in high-value or rare commodities.
Okay.
If we could reduce travel times between stars to weeks or months, imagine transporting rare minerals or unique biological materials from other planets.
Okay. It could become economically viable, and that would totally change how we think about trade and economics.
But that kind of long-distance trade would require some pretty sophisticated financial tools.
What? Oh, absolutely.
We're talking about investments that might not pay off for generations.
Exactly. We'd need incredibly advanced futures markets.
Right.
Investment strategies that are designed for returns that might not materialize for decades or even centuries.
Wow.
And then there's time dilation.
Right.
Even at subluminal speeds.
Right. Even those subtle effects of time dilation could really complicate trade agreements and interest calculations.
Yeah, that's something we don't have to worry about too much here on Earth.
Not yet.
So we'd need standardized timekeeping across interstellar distances.
Yeah.
and new legal frameworks that take time dilation into account.
Exactly.
And then there's the whole issue of resources, right?
Yeah.
Asteroids full of precious metals, moons with vast reserves of water ice.
Right.
The potential to solve a lot of our resource problems here on Earth seems huge.
It does. And your sources really emphasize the importance of in situ resource utilization.
Which is?
Being able to extract and process resources directly from celestial bodies.
Okay.
Like getting water and oxygen from the moon or from asteroids.
Right.
That would dramatically reduce the cost and complexity of space-based industries and make them much more economically viable.
It's like living off the land, but in space.
Exactly.
But who owns those resources, right?
Right.
It seems like that could lead to all kinds of disputes and conflict.
That's a big question, and your sources brought up the need for clear international agreements.
Yeah.
Maybe even new types of property rights that apply beyond Earth.
Right.
We have to figure out how to manage these resources fairly and prevent conflict.
And even beyond just the trade and the resources, just trying to develop warp drive technology would probably create all kinds of new industries here on Earth, wouldn't it?
Absolutely. And we're talking about a massive expansion of the aerospace sector, designing, building, and maintaining warp-capable spacecraft.
Right.
This would drive innovation in propulsion systems, new materials, energy generation, and storage.
Right.
Even life support technologies for long interstellar journeys.
And what about space tourism?
That's another potential industry.
Yeah.
Initially, for the very wealthy, of course.
Right.
But think about all the supporting industries that would spring up around that.
Like what?
Interstellar navigation services, near instantaneous communication networks,
right,
shipping and logistics companies for interstellar trade,
yeah,
and, of course, financial institutions that can handle interstellar transactions.
Right, we talked about that. It's like a whole new economy built around warp drive.
Right.
And maybe one of the most direct benefits here on Earth could be the advances in energy production and storage. I mean, if we need that much energy for warp drive, we're going to have to come up with some pretty amazing new technologies.
That's right. The need for incredibly efficient and powerful energy sources for warp drive could lead to breakthroughs that revolutionize our energy infrastructure here on Earth.
Like what?
Compact fusion reactors, new ways to store energy.
Right.
I mean, the possibilities are really exciting.
So the economic implications are pretty mind-blowing.
They are.
But your articles also talked about the potential social and cultural shifts.
Right.
And those might be even more profound.
They could be.
This idea of permanent human settlements on other planets, I mean, that changes everything, doesn't it?
It really does, if you think about the long-term survival of our species.
Yeah.
Establishing self-sustaining colonies on other planets is like an insurance policy.
Right.
But beyond that, think about all the different environments these planets might have. Different gravity, different atmospheres, different radiation levels.
Yeah.
Over time, those conditions could shape human evolution in very different ways.
Right, like we might end up with different kinds of humans adapted to different planets.
Exactly. Over long periods of time, we could see new branches of humanity emerge.
Wow.
New subspecies adapted to different worlds.
That's kind of a scary thought, but also really exciting.
It is, isn't it?
And what about our sense of who we are? If home isn't just Earth anymore,
right,
how does that change our identity?
Your sources suggest a real transformation in our sense of place and belonging.
Okay.
Home could become much more fluid. It could include not just Earth, but the worlds we've settled.
Right.
The network of interstellar communities that connect us.
Yeah.
And this could lead to new kinds of societies with shared values and a collective identity that goes beyond any single planet.
It's like a whole new level of human connection.
Yeah.
And then, of course, there's the big one, first contact with extraterrestrial life.
Right.
That would be a change, unlike anything in human history.
It would. And, it's fascinating to think about how it would affect human culture and our whole understanding of the universe. Discovering that we're not alone would challenge our assumptions about our place in the cosmos.
Yeah.
And it could lead to a reevaluation of our values and beliefs.
And just imagine what we could learn from another intelligent species.
Exactly. Cultural exchange with alien civilizations could lead to incredible advances in knowledge.
Yeah.
But your sources also pointed out the risks involved.
Like what?
Well, their way of thinking might be so different from ours.
Right.
That we might have trouble understanding each other.
Right.
So we'd have to be very careful about how we interact with them.
And as we expand out into the cosmos, we've got a huge ethical responsibility, don't we?
We do.
Your articles talked about the potential impact on alien ecosystems.
Yeah.
And this idea of not interfering with other civilizations that might be less advanced than us.
Right. Those are crucial considerations.
Yeah.
We have to think carefully about the potential for disrupting any life we might find on other worlds.
Yeah, even if it's just microbial life. And this idea of non-interference, especially with civilizations that might not be as technologically advanced as us.
Yes, that's a really important ethical principle.
We don't want to repeat the mistakes of our own past.
Exactly. We need to balance our desire to explore and maybe even use resources from other planets.
Right.
With the responsibility to avoid causing irreversible harm to those environments.
Right.
And to respect the potential for life in whatever form it might take.
And making sure that the benefits of interstellar travel and any resources we find are shared fairly.
Right.
I mean, that seems like a massive challenge.
It is. We don't exactly have a great track record of equitable resource distribution here on Earth.
No, we don't.
So preventing the widening of existing inequalities on an interstellar scale,
Yeah.
that's a huge ethical hurdle we need to overcome.
So we've covered the science, the potential economic impacts, the social and cultural changes, the ethical challenges. Now let's talk about the geopolitical landscape.
Okay.
What happens if one nation or group manages to develop a working warp drive first, especially a faster-than-light one?
Well, your sources suggest that the first to achieve a working warp drive, especially one that allows for faster-than-light travel, could gain a huge advantage.
Like what kind of advantage?
Strategic and economic advantage on a global scale.
Right.
It could trigger a new kind of space race.
Yeah.
And think about the military applications.
Yeah, sure.
Being able to rapidly deploy forces across vast distances.
Right.
That could completely change global security strategies.
But on the other hand, this is such a huge undertaking.
It is.
So expensive, so complex,
Right.
that it might actually force more international collaboration.
That's a good point. The sheer scale and cost of this kind of research and development
Yeah.
could lead to unprecedented levels of cooperation between nations.
Right. They might have to pool their resources and expertise to make it happen.
Exactly.
And what about interstellar colonization, governing territories that are light years away?
Yeah.
I mean, that sounds incredibly complicated.
It does. And your sources highlighted the logistical challenges of establishing and governing interstellar colonies.
Yeah.
Transporting people and resources across such vast distances.
Right.
Maintaining order and governance in these far-flung settlements.
Right.
It would be incredibly difficult.
And it could lead to some really interesting new political entities.
It could. Over time, we might see the emergence of independent interstellar nations.
Wow.
And the relationship between Earth and its distant colonies could evolve in ways we can't even imagine.
And of course, we can't forget about the biggest wild card of all, first contact.
Right.
What happens if we encounter another intelligent species?
Well, the geopolitical ramifications are almost impossible to predict.
It could go so many different ways.
It could unite humanity against a common other,
Right.
but it could also exacerbate existing tensions,
Right.
create new divisions based on how we interpret the alien presence,
Yeah.
their capabilities, their intentions,
Right.
and how we should respond to them.
It's like the ultimate unknown. So let's go back to some of those ethical questions, especially when it comes to interacting with alien civilizations, especially if they're less advanced than us.
Right.
Does this idea of a prime directive, this rule of non-interference from Star Trek, does that actually hold any weight in this discussion?
I think it does. Your sources brought up the ethical dilemmas of interacting with less technologically advanced civilizations. And the idea of a prime directive is really about our responsibility to avoid disrupting their development, their culture.
Right.
We have to think about the long-term consequences of our actions.
Yeah. What kind of impact are we having on these other civilizations?
Exactly.
And what about the ethics of resource extraction if we find life on other worlds, even microbial life?
Right.
Where's the line between our needs and preserving these alien ecosystems?
That's a crucial question.
Yeah.
Your sources emphasize the need to balance our potential need for resources with the need to protect and preserve these extraterrestrial ecosystems,
Right.
no matter how simple they might seem to us.
Right.
So we need to develop ethical guidelines for how we explore and potentially utilize resources from other planets.
And we have to prioritize understanding and preserving those ecosystems.
Absolutely.
So let's have some fun. Now let's get into some of the really far out speculations.
Okay.
What are some of the most mind-blowing long-term possibilities of mastering space-time manipulation for warp drive?
Well, your sources hinted at some truly profound possibilities.
Like what?
If we can figure out how to manipulate space-time for warp drive, it could lead to major breakthroughs in our understanding of the universe.
Like what?
I mean, we might finally understand the true nature of gravity,
Okay.
the relationship between space and time. We might even be able to unify quantum mechanics and general relativity,
Okay.
which is one of the biggest mysteries in physics.
Right.
So the implications go way beyond just space travel.
And what about the long-term impact on us? Could interstellar travel and living on other planets actually change human evolution?
Over very long periods of time.
Yeah.
It's definitely possible.
How?
Well, different gravity, different levels of radiation,
Yeah.
different atmospheres,
Right.
all of these factors could drive biological adaptations,
Right?
and that could lead to the emergence of new human subspecies.
Wow.
Different kinds of humans adapted to different worlds.
It's incredible to think about.
It is.
And the philosophical and existential implications are almost too big to wrap our minds around.
I know. It's really hard to grasp the full scope of what this could mean for humanity.
So what's the most likely path to the stars?
Uh-huh.
Will it be one big sudden breakthrough or a more gradual process?
Your sources suggested a few different possibilities. An incremental approach seems likely at first,
Okay.
focusing on subluminal warp drives for near-term interstellar missions.
Okay.
But of course, a major breakthrough in energy generation
Right.
could speed things up dramatically.
Right.
And there's always the possibility of a wild card,
Like what?
like discovering evidence that another civilization is already using warp drive technology
Oh, wow. Yeah.
that could give us a huge leap forward.
Yeah, we could learn from them.
Exactly.
But there could also be resistance to this whole idea, right?
Right.
People worried about the cost, the risks, the ethical implications.
Of course, those are all valid concerns.
So how do we overcome those barriers?
Well, we need transparency in the research.
Okay.
We need to clearly demonstrate the benefits, the safety of warp drive technology,
Right.
and we need to have open and honest public discussions about the implications.
So everyone understands what's at stake.
Exactly.
Well, this has been an amazing deep dive.
Yeah.
I mean, it's incredible to think that something that used to be pure science fiction is now a serious scientific pursuit.
It is.
With the potential to change our planet and even our species.
Uh-huh.
We've talked about the science, the economics, the social and cultural impacts of the geopolitics, the ethics, and some really wild, long-term speculations. And it's all based on the incredible material that you sent in.
And your sources really highlight the amazing potential of this technology.
Yeah.
I mean, it could unlock the resources of the galaxy,
Yeah.
enable the expansion of human civilization beyond Earth,
Right.
give us a chance to survive long-term,
Yeah.
and creating incredible opportunity for our species.
But we also have to be aware of the challenges.
Yes.
The technological hurdles, the ethical dilemmas,
Right.
the geopolitical complexities.
Right.
Yeah, it's a lot to think about.
It is.
So as we imagine this future among the stars, it really makes you wonder, maybe developing warp drive isn't just about reaching other stars. Maybe it's about changing ourselves.
Right.
About becoming the kind of civilization that can handle this kind of power.
Yeah.
Whether we ever meet another intelligent species or not.
Exactly.
That's something to ponder long after our deep dive today.
It is.
Thanks for joining us.
Thank you.
And for sending in this amazing material.
You're welcome.
It's given us a lot to think about.
I'm glad to hear that.
So until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
Our podcast, AI Voices, are courtesy of Notebook LM and 11 Labs, the humans and AIs of the AI Plus Roundtable. Thank you for joining us on this journey into uncharted territories.
Visit us on Substack at airoad.substack.com for free access to our other expeditions into the unknown. We thank our producers, the humans at Innovation Toronto and ChatGPT, Claude, Cohere, Copilot, DeepSeek, 11 Labs, Gemini, Grok, Llama, Mistral, Notebook LM, and Perplexity for co-creating the research used to create this podcast. We look forward to welcoming you on board. for our next explorations into uncharted territories.